Educational Communications and this station present Environmental Directions with Nancy Pearlman. On this series, we explore the effects of human influence on the Earth's ecosystems and discuss solutions to environmental problems which affect the quality of life on this planet. Environmental Directions gives you the kind of information you need to help you participate in decisions impacting your community, the nation, and the world. Now, here's your host, Nancy Pearlman.
Hello, my guest is Professor Marks Johnson. He is Professor Emeritus, Charles L. McMillan Professor in Natural Science Department of Geosciences at Williams College. He has authored numerous peer-reviewed articles, geology textbooks, and popular books on Baja California. His most recent book is Baja California's Coastal Landscapes Revealed, Excursions in Geologic Time and Climate Change. Welcome back to Environmental Directions.
Thank you very much, Nancy. A pleasure to be back with you again.
Last time we talked about the geology of Baja California and some of the discoveries, and we're going to talk more about the unique area. But let's begin with explaining why this peninsula even exists. And in reading your book, I was surprised to learn about so many little islands in the Gulf next to Baja California.
Yes, there are something like 40 named islands in the Gulf, ranging in size. Some of them are quite large. I think the largest one is some 360 square miles, and then lots and lots of really tiny islands. So I've been to maybe just about 15, most of the big ones and some of the really small ones as well. The interesting thing about the islands is not just the peninsula, of course. The peninsula has a very long coastline. The western coastline is something like 850 miles long, but the islands are almost like little weather stations. In other words, if you go out to an island and you start looking at some of the deposits, those deposits are telling you about change through time in one particular spot or one particular place. So that's very useful when you're trying to put together the story about how the Gulf actually appeared in the beginning.
You mentioned a lot about the Pleistocene, but you have other geologic periods. Give us those millions of years of era and what is most obvious there in Baja California.
These are just technical terms. So Pleistocene is an era or a kind of a period that began about 5 million years ago. It's like nature rang a gong and it's okay, time's up. About 2 million years ago, it was finished. Now, within that time, there were changes in sea level, and there were these storms, these really big storms that were occurring locally there in the Gulf of California. The Pleistocene is just really our most recent epoch. It's distinguished by, in the northern hemisphere, farther to the north, major glaciations, the coming and going of ice ages. So, for example, where I live here at Williamstown, at Williams College, it was covered multiple times by thick ice that came down from Canada and then would melt and recede and go back. Ice never occurred that far south in Baja California, but of course the temperature would change. It would be a lot colder during a glacial period, and then in an interglacial period, it could be even a lot warmer than it is today. So part of the book deals with the last interglacial stage, which was about 125,000 years ago, not very long ago at all. Coral reefs, because the water was so much warmer, coral reefs could basically extend or migrate much further north into the Gulf than where we find them today. So these are some of the markers that are laid down that tell us about the difference between the Pleistocene and the Pleistocene.
When did Baja California, the peninsula, break away from the mainland?
The first crack began as far ago as about 12 million years ago. It was a very slow sort of process. It could well be that in some places it was a little bit like the Dead Sea or like other places that are quite low below sea level but don't have much water yet, maybe just river water coming in. So there may have been a kind of a dam at one point that kept a lot of the seawater in, but suddenly about 5 million years ago, the way was open for marine water, normal salt water, to actually pour into the place. And of course, at that time, it brought with it all the kinds of marine organisms like corals, and like all the different kinds of mollusks that we find, that would come in with the seawater as well. So there's where we really are fascinated by looking at the limestone that is forming just off the shore, where we have all these igneous rocks like granite and rhyolite. And the juxtaposition of the two types of rock are really telling us about an evolving shoreline and an evolving body of water.
You have some beautiful pictures. You have some interesting maps of the areas as well. It's a desert?
Yes, it's a desert landscape by the sea, which is a kind of an oxymoron in the sense that it's generally a very dry environment, so there are a lot of cacti, but at the same time, this ocean water, this marginal sea, this semi-enclosed sea, is incredibly fertile. So you can be hiking along the shore and all of a sudden you'll see whales that are breaching, or you'll see a pod of dolphins that are surfacing and fishing, and so on. And of course, lots of birds, lots of pelicans, lots of other kinds of birds, fishing birds. For a geologist, the landscape, because it is dry, it means you can see the rocks. It's not covered with grass and with thick forest. But at the same time, you get this feeling of an incredibly rich ocean.
Because the peninsula is on the ocean, on the Gulf, it has a lot of marine life. But the desert also has life, flora and fauna that's special to the area. Are there rare and endangered species that need to be protected in this locale?
Well, yes, of course. One of the things that I could mention from the fossil angle is that, of course, cacti are very unusual. They're really a kind of a North American thing. We don't find cacti elsewhere around the world unless somebody actually sends a cactus as a gift to somebody. But the fossil record of cacti is virtually unknown. So there is one locality where we think we have a chance, it could be something that we will solve in the future, to actually find preserved fossil cactus wood. Now, cactus wood is quite unique. When you find a cactus that has died, there's an internal skeleton, and these can be quite different from species to species. We did find one locality where this material was being preserved in a hot spring, where mineralization was occurring that could preserve the wood texture. We did find fossil plants, but not yet have we found the actual cactus plants.
It shows that collaboration needs to occur between scientists, geologists, botanists, biologists,
Absolutely.
even anthropologists. So much to be discovered. But what kind of rocks are there?
In the beginning, in some of my earlier books, I was mainly interested in limestone. And limestone was sort of paralleling the opening of this gulf. Most of the seawater that came in about 5 million years ago. So if you could date the limestone, you knew when some of the earliest ocean water was coming in. And of course, the limestone is an organic type of rock. It can be made of corals, can also be made of things like pectins, these large shells, or it can be made of a really peculiar type of coralline red algae called a rhodolith. So that was what first attracted me to the area, was sort of mapping out these limestone deposits that were parallel to the shoreline.
But volcanic rock is also there, because Baja is part of a massive area around the Pacific Ocean called the Ring of Fire.
Yes, so these limestones are actually abutting against mostly volcanic rocks, and sometimes these are very simple, essentially just granite, for example. So it can be very striking to see a kind of a white limestone juxtaposed directly against sort of this reddish granite. You know that you're on a paleo shore, and if you can study the fossils and look at how they've changed through time, then you might be able to see that, oh, this shore was 5 million years old, this later shore was 3.5 million years old, and very young ones that are only just a few thousands of years old as well. So that's what initially got me started, was this idea of tracing the history. Where did this marginal sea come from? It's a piece of territory that split off from mainland Mexico along this edge of the Ring of Fire.
When and how and why did it split off?
Well, there's something called the East Pacific Rise. Now, in the Atlantic, there's something called the Mid-Atlantic Rise, which is very easy to understand because it goes right down the middle of the North and South Atlantic. It's a kind of a ridge, a submarine ridge, where seafloor spreading is occurring. So the Atlantic is getting a little bit wider every day through this volcanism. Now, in the Pacific Ocean, which is, of course, the world's biggest ocean, this ridge is offset to one side. It's not in the middle. And that's because the whole eastern part of the ocean has already been subducted down underneath South America and North America as well. So it's disappeared. And of course, when the rock is subducted, and these are mostly basalt, that material is melted at great depth, and it becomes new magma. Anything that's hot, like a hot air balloon, is going to rise. And so these hot rocks find cracks and crevices and ways to come to the surface where they appear, of course, as volcanoes. The Andes Mountains are a huge, continuous line of volcanic mountains, all the way from the tip of the peninsula through Chile and on up through Peru and so forth. Likewise, of course, we have similar mountains in North America as well. The Cascade Range, for example, north of you in Oregon and Washington. The interesting thing is that there's kind of a gap. These mountains ceased to exist once Baja was pulled away from Mexico. We still have these mountains to the south in Mexico, but it turns out that this wedge of rock that was split off from Mexico has been sort of hijacked, if you will, and is now part of the big Pacific plate.
Politically speaking, we've divided Baja California, which is in Mexico, with Alta California, which is in the United States, and we've just eliminated the word Alta to California.
Right. Alta just means above or upper, and Baja just means lower as well.
But geologically, what is the connection? Because we still have the Sierra Mountains with the highest peak in the continental United States rising to over 14,000 feet.
The San Andreas Fault is the key here. So in other words, you go to the top of the Gulf where you find the Colorado River, emptying into the Gulf. But there's this huge fault system. There's more than one, just the San Andreas, but there's a system that snakes its way all the way up through and comes out north of San Diego. So the Gulf is not finished. That's the interesting thing. It's a very active place tectonically. Originally, the Spanish explorers thought that the whole thing was an island, and if you sailed into the south, you could sail right up to the north and come out in the Pacific Ocean further north. In the future, it's far overdue, of course, the next big earthquake. Eventually, this whole thing is going to open up as a through-going seaway. And not only that, the entire sliver of land will continue to move to the northwest gradually with time. It's like a centimeter a year or something like that. It's a very slow movement. But this is part of what really makes the place absolutely fascinating as a kind of a laboratory where you're not only looking at the lithosphere, the rocks themselves, and how they interact with the hydrosphere, the oceans, but also this latest book has really focused on storms, on the atmosphere, and how these three cycles kind of interact with one another.
And you have some great stories about the storms taking students from Mexico into the area and how they're familiar with El Niños. Your book is written for both the scientist and for the regular person who wants to learn more about our landscapes and what to go see and what to go enjoy, because you've written it in a way of your travels, your trips to the locales. And you even talk about the historic trip of Steinbeck to the region.
Yes, that's right. Steinbeck, of course, with his good friend, the marine biologist, Ed Ricketts, rented a trawler in Monterey. It was just before World War II, and they made this long trip down through the Pacific, turned the corner, and went up into the Gulf of California.
But he didn't write the book until the 1950s.
Well, they did write the book before the war. It didn't sell well, and it had a whole second half that was filled with biological details. Ricketts was a marine biologist, and he was interested in the intertidal rocky zone. So they're wonderful stories that are recorded. But in 1950 or 51, Ricketts had actually passed away by that time. They re-edited and took out a lot of this very detailed biology and just kept the diary, which was something that Steinbeck had actually kept. But of course it was full of all kinds of fun stories of different things that happened to them.
And you yourself keep good detailed diaries of your excursions, which you have published in Baja California's Coastal Landscapes Revealed, Excursions in Geologic Time and Climate Change. And it was fun reading to find out about how you decided to go hike here or to walk there and what to explore and how easy it was and how difficult it was to get around.
Sometimes it was just pure chance. Usually we would go down in January. The weather is just fantastic in January and even through March as well. But at the end of one field season, you're always wondering, well, I would like to come back again, and what should we do next?
And as a geologist, you're focusing on rocks, and yet throughout your book, you're talking about the unique fossils, because fossils are preserved in the rock. How does that happen, and what kind of animals did you find from the past, and which of those still exist now?
Yeah, so for example, there's one very large reef. One of the chapters in this new book deals with a place called Cabo Pulmo, which has a living reef today. That reef is at the northern limit of what we would see today. It can't expand northward because the waters are too cold. What's really startling in a way is that if you go back into the past, then even 100 kilometers further north, you can find a fossil reef that's actually exposed right there, just as though there was a bathtub and somebody pulled the plug and the water went out and the reef is there. This is telling you that climate was different. Let's say a few 100,000 years ago, it was much warmer, and corals were able to expand northward much further than they are today. But of course, we have other reefs that are even older. Some of them go back a good 5 million years. So that's one type of a limestone. It's a coral reef limestone. But there are other kinds of limestones as well. And the beauty of doing this work in the Sea of Cortez is that if you're flummoxed by something that you find as a fossil, you can just sort of turn around and wade into the water, and you're very likely to find the same kind of organism today that will kind of satisfy that mystery or solve that mystery as to what is this.
I want to hear more about your discoveries and excursions in Baja California when we return in a moment with my guest, Professor Marks Johnson, who is Professor Emeritus at Williams College.
Environmental Directions with Nancy Pearlman continues with further discussion of the world's critical ecological issues. For more information, you may call 310-559-9160 or go to www.ecoprojects.org. Now, here's Nancy.
I'm speaking with Professor Marks Johnson. He has authored numerous books, including his latest, Baja California's Coastal Landscapes Revealed, Excursions in Geologic Time and Climate Change. And while your book focuses on different trips, hikes, discoveries in different areas, you had one chapter about the San Basilio Bay, and the main city is Loreto, which is a nice tourist place to go. I think I need to get down there.
Yes, well, so Loreto, you'd have to go north about 30 miles or so. You can either go by road or you could go by boat to get to this beautiful little bay called San Basilio. It's a fantastic place. I think it was about 2001 maybe when I spotted this for the first time, and it was one of these things, aha, this looks like a wonderful place. Sooner or later, we're going to have to come back with students and figure out what is going on there. So very often, in fact, I would end a trip and stay at a wonderful place called the Spanish Countess's house. We would explore, and I would have the students do some mapping. They would go out with a topographic map, a set of colored pencils, and they would color in a different color for each type of rock. But it was a very mystifying place. It was very, very hard to understand.
The Spanish Contessa built this house in a very remote area.
Yes, at the time she built that, there were no roads connecting to the place. It was probably in the 1960s, and she probably was on a cabin cruiser or a sailboat and came into this bay. She called it Agua Magica. It's a partly sheltered bay, beautiful with the sunrise and sunset every day. And she decided that she was going to build a house there. There's no fresh water, so originally she put in a desalination plant. There was a swimming pool that she had. It was a really opulent sort of place.
In reading your book, I learned a lot about rocks. I learned a lot about different geologic periods of time, like the Pleistocene. It's not heavy on the cultural history because you pointed out that the missionaries back hundreds of years ago basically gave the indigenous people so many European diseases that they died out.
Yes, so this was one of the big problems, right? They had a good heart, right? The idea was, in fact, that they wanted to keep out most non-religious people. In other words, originally it was the Jesuits that came in, and they were followed by Dominicans and other groups. They had just enough Spanish soldiers to protect them, but the idea is that they were going to civilize these people. They were going to teach them how to become agrarians and have farms and so forth. Loreto, in fact, is the mother mission. It's the first between Baja California and Alta California, but there are a lot. Well, most of them were adobe, and they didn't really stand up to time very well, but a handful of them are actually made from solid rock. They had stonemasons, or they trained some of the Indians to be good stonemasons, and some of these are quite beautiful. And they did wonderful things. They did bring in grapes, for example. They brought in olives. They brought in various types of plants, and really did try to set up an agrarian system. But of course, something like smallpox would come in the end, after 50 plus years or so, there were something like maybe 5 or 6 different indigenous tribes. They all got wiped out. There's only one left, and that's on the mainland side. The Seri Indians occupy the largest island in the Gulf. That's still a reserve. They are protected because basically they keep people out.
Could you give me a super brief summary of your semester-long geology courses about what we would see in terms of the rocks, the fossils? You keep talking about many different kinds of rocks and fossils that you have found, you have photographed, they're in your book. What's a rhyolite, and why are the washes so important to the area, and the conglomerates that you find of other old species of bivalves which still exist today?
Sure. Well, the San Basilio area is interesting just because of this combination of rocks that you've mentioned. And the front cover of this particular book, California's Coastal Landscapes, shows what we call rhyolite spires. They actually look like a church spire that's kind of rising out of the ocean. Rhyolite is basically the same as granite, except that it's a very fine-grained rock, whereas a granite, which occurred at great depths in a kind of a caldera deep down under, that material cooled very slowly, and the crystals are quite large. So these spires are actually a volcanic neck. They're actually the throat of a volcano. The magma is rising up from the basin itself, or the caldera. Of course, most of it spits out the top and makes a lava flow, but some of it gets caught in the throat and hardens. So when we look at these spires, we're actually looking at the neck or the throat of a volcano. The surrounding volcano slopes have been eroded away, but you're stuck with this resistant sort of rock. So it's a technical term, of course, rhyolite, just as granite is another technical term. They represent the same type of chemical association, lots of silica, for example, grains that are in both kinds of rock, but the rhyolite is more typical of the lava stage of this material.
What about the fossils, the bivalves, the pectins,
Yes.
and others?
So the interesting thing about the main locality inside the bay is that you can reconstruct the island a small island that surrounded one of these volcanic peaks. And most of that was limestone, except that the shores, or the coastline around the volcano, of course, which was circular, was very, very steep. It's like you're going on a trip, let's say, to a place, let's say a dormant volcano, and you decide that you're going to put on some snorkeling gear, and you're going to dive down along the coast, down underwater. And what you would see would be thousands and thousands of scallop shells, pectin shells. They lived along the shore, but when they died, the shells would separate. There was nobody there collecting the shells. This was really well before human beings were around in this area. So the shells would separate. They would be loose along the sides of the volcano. And if a storm came along and the waters were agitated, there would be sort of a submarine avalanche, and these shells would be washed down to even deeper water. It's interesting, at this locality, you can actually sit, it's as if you're underwater, and you can sit along the side of a volcano, and you can experience some of these underwater avalanches as more and more shells come into the area. And then every once in a while, if there is an explosion, you'll find volcanic ash that is sifting down through the water, almost like a curtain in a way, and settling maybe to make a little seam of ash. And then the whole thing would start over again. So part of it is putting yourself back in time. I mean, geologists are really time travelers. That's what we do. We go to a place and we try to imagine what the environment was like when the rocks were actually being deposited. And San Basilio is just one of those places that is charming. Well, it's very violent, actually. There were sea storms and volcanoes, but you can sit there on a beautiful morning with the sun rising, and you can imagine yourself witnessing these events as they occurred long ago.
Our previous interview focused on your book, Gulf of California, Coastal Ecology, Insights from the Present and Patterns from the Past. I thought that this one was going to be pretty much the same, but it was so different. Your new book, Baja California's Coastal Landscapes Revealed, Excursions in Geologic Time and Climate Change, made me feel as though I'm there exploring, looking, discovering with you, because you described the day field trip and how you decided what to go see, what the difficulties were, what you found. There are so many great stories in your book, but I'm curious how you decided to add the word excursions in geologic time and climate change, because you're not dealing with climate change as so many of my guests have in terms of what we need to do to reduce emissions and to stop the change in climate, but you have really shown that over time, climate makes a big difference in the geology.
Yes, absolutely. There's a kind of a trick phrase or stock phrase when teachers are lecturing in historical geology, and that is the present is the key to the past. You're using the experience of today to help you understand and to sort of demystify the rocks that you're seeing in the past. Now, the thing that's really different about this book is that one of the arguments is that major storms were far more common in the past than they are today. That climate went through a period of global warming that preceded what we're experiencing today. So the book is really kind of a wake-up call then. You're in a lovely, beautiful place, but the rocks are screaming at you, and they're telling you that there were severe changes in climate that were going on maybe between 5 and 3.5 million years ago, such that basically an El Nino effect was more or less not coming every 5 or 6 years, but was there every year. And there was a really substantial amount of coastal erosion, and the deltas that were feeding into this body of water were just discharging an amazing amount of material into the sea.
You, along with Mexican scientists and others, have explored this area extensively. What have been some of the discoveries that were unexpected?
The biggest discovery, maybe that I'm the most proud of, is on an island called Isla Del Carmen. It's maybe the fourth largest island in the Gulf. It's got one of these huge deltas on it. This delta is composed of conglomerate, large boulders of rock that have come off the center of the peninsula and washed down through stream beds to reach the east coast of this island and form a very, very thick, it's about 200 feet thick, and the whole deposit is about 1.25 miles wide, and it forms a huge arch. When you look at it from the sea, it looks like an arch. It's a classic cross-section through a huge river delta that has reached the sea. The odd thing that is very characteristic of this feature is that you can actually map out maybe 10 different units where the stuff was just flushed in huge amounts, which meant that there had to be a lot of rain on the peninsula itself to discharge this volume of material down through these tributaries and onto the sea. When this material reaches the coast, it's what we call a tidewater delta, and we can tell it was at the edge of the sea because we have a few marine fossils that are intermixed with this conglomerate. So it was just a huge area, and for many years we scratched our head, and what could this possibly be? And it finally kind of came together that we could figure out that this was, in fact, an ancient delta.
I'm sure that as a scientist it was wonderful to make those kinds of discoveries and conclusions. What do you expect to find in your next excursions?
Well, that's hard to say. It's a very gradual process. Oftentimes there are surprises. So part of it is just becoming comfortable with sort of figuring out how nature works, the interaction of the lithosphere and the hydrosphere and the atmosphere.
I am sure that you're going to continue to write your articles and probably another book about different aspects of this area that you have fallen in love with as a geologist exploring Baja California, and I look forward to reading more of your work. I want to thank you so very much for sharing this land with us. Thank you for being my guest.
My pleasure. Thank you.
I have been speaking with Professor Marks Johnson, who is Professor Emeritus, a Charles L. McMillan Professor in the Natural Science Department of Geosciences at Williams College. I'm Nancy Pearlman. Thank you very much for joining us, and do tune in again next week.
If you would like free information about these environmental issues, go to www.ecoprojects.org or call 310-559-9160. Environmental Directions with your host, Nancy Pearlman, is a community affairs program of the nonprofit organization Educational Communications and this station.